Alright, let's look at the homework 4.1, problem number 9. So we want to find the absolute maximum and the absolute minimum of this function right here over the closed interval from -1 to 4. Alright, so let's do that. Alright, so we're going to apply the closed interval method, and so we need to find critical numbers. So we take the derivative f prime of t is equal to, alright, so I don't like square root, so I'm gonna rewrite this guy as t times, alright, quantity 16 minus t squared raise it to the 1/2 power, which is equivalent to square root. Alright, so take the derivative of that using product rule. So this is the first guy and this is our second guy. Alright, so derivative of the first guy is 1 times the second guy, so quantity 16 minus t squared, raise it to the 1/2 power. Alright, plus first guy is t times derivative is 1/2 in front, keep the same inside function, subtract 1 from the power, so it's -1/2. Then you would have to multiply by derivative inside, which is going to be -2t. Right? Then if you simplify that, you will get this. Alright, so this guy is going back to square root of 16 minus t squared. Alright, then we can cancel 2 here and 2 here. So you would have negative the t here and t there, negative t squared, and over, because you have a negative power here, then you have a square root of 16 minus t squared. Right? By taking a common denominator, we can write it as let's see, I'm gonna probably go down here. Right? So taking a common denominator, so we would take square root of 16 minus t squared. Alright, then we would have to, let's see, square root of 16 minus t squared would be 16 minus t squared. Alright, then you have minus another t squared, so I'm going to put 2 there. Alright. Then we can clean up a little bit. So we factor out 2. So it's a 2 times 8 minus t squared and divided by square root of 16 minus t squared. Alright, then let's look for a critical number by setting this guy equal to 0. Alright, so this will give us, right, we just have to make sure that the numerator equal to 0. So t squared has to be equal to 8. So you can see that the t is going to be plus or minus square root of 8. Right? Or 2 square root of 2, which is the same thing. And also the derivative is undefined when t is equal to either +4 or -4, because the denominator equals 0. So t equals plus or minus 4 would be a critical number 2. Alright, but remember that the interval is -1 to +4, so we don't have to consider negative square root of 8, so that will be too small. So we have to look at the positive square root of 8. And also -4 and 4. -4 is not in there, so just +4. Alright, so then we have only 3 candidates. So we just have to look at f of -1, which is the left end point. Alright, then you have to look at square root of 8. And also you have to look at 4, f of 4. Alright, so let's compute that. So this is going to be, so original function t is -1. So it's going to be a negative square root of Alright, a 16 minus a 1 square, so it's going to a negative 1 square would be 15. Alright, so negative square root of 15. So if you put square root of 8, so that's going to be equal to square root of 8, so that's t. And then you have a square root of 16 minus a square root of 8 squared. So 16 minus 8. So you have another square root of 8. Right? So that's going to be 8. Right? Then we plug in 4. So it's going to be 4 times. And 16 minus 4 squared is actually 0. So actually 4 times 0 is actually 0. Right? So you can see that here, this guy is the absolute minimum, because this is the smallest one. And this guy is the absolute maximum, because it's the biggest one. Right? So let's type it in. Right, absolute minimum value was negative square root of 15, and maximum value is 8. Right, so let's check the answer. Submit for testing. Alright, it came back and looks like we got these guys correctly. Alright, that's it. I hope that this was clear.